Greetings, everyone. Let's talk about complex numbers, which was a topic of Chapter 9 that we had to learn about and do some manipulatives with. All right, so a couple key things. A complex number looks like this form a plus bi that we see right over here, and where I is equal to the square root of -1. And so we have to learn to manipulate those expressions in some certain simple ways for this chapter. So let's start with, some real basic stuff here for a moment. So we know that the square root of 4, with the square root symbol like this, the positive square root of 4 is equal to 2. Now, before we worked on this section here, when we would have to take the square root of a negative, we would say that you can't, the number doesn't exist. But now with the introduction of complex numbers, we can now handle taking the square roots of negatives, under this with this relationship that I is equal to the square root of -1. So what we would do is we would break the -4 down into the product of 4 and -1. And then once I've broken it down into that product, then I can separate the square roots the square root into two separate square roots. So I get the square root of 4 times the square root of -1. And the square root of 4, as we mentioned above, is 2. And also, as we mentioned above, the square root of -1 is I. And so root -4 can be rewritten as 2I. That's an equivalent form. So to illustrate that with another example, if we're dealing with the square root of -9, we could, again, break this down into 9 times -1 under the square root. And then we just take the square root of each term individually and multiply the results together. And so this becomes 3 times I. We could have an example where we have the square root of -5. And when I try to do this, it's not quite as straightforward in one sense, because 5 is not a perfect square, so I can rewrite this as the square root of 5 times the square root of -1. But the square root of 5 is not a whole number, and so I could get a numerical approximation from my calculator. I could plug that into the calculator and get a result, but if I want to leave it exactly, then it's the square root of 5I, like this. Sometimes we like to write the I in front of the square root symbol, so it's not to be confused, that we're the square root stops before it gets to the I. Sometimes people draw a little vertical line like that. So this is a basic manipulation when it comes to dealing with square roots of negative numbers that you should become comfortable with. Okay, so with that said, complex numbers, as mentioned at the start of the video, look like the form A plus B times I. We call the A part the real part, and we call the BI part the imaginary part. And so A and B are both real numbers, but we multiply the real number B times square root of -1, or I, and then that becomes the imaginary part. When we want to add, subtract, multiply, divide, we treat them like we do most other numbers or expressions that when we add them together, we want to add like terms. So if I'm adding 3 plus 4i with, let's say, -6 plus 2i, like this, I would add the real parts together, and I would add the imaginary parts together, and then from there I'd get the results. So my real parts, in this example, are going to be 3 and -6, and when I add those together, 3 plus -6 is -3. My imaginary parts are 4i and 2i, which makes a total of 6i. So addition is pretty straightforward, or it should be at least. If we want to subtract, it's awfully similar to that. We would just distribute the negative sign. So we could do something like this. If we had, let's say, -3 minus 7i, and then we subtract 4 plus I, well, you can think of it as -3 minus 4, and that gives us, of course, -7. And then we can take this -7i and subtract I from it like this, which makes negative 8I. Break it down. And then our result is going to be negative 7 minus 8I. What if we wanted to multiply them together? If we're going to multiply them together, then we get, like 2 minus 5I times 3 plus 8I, or something like this. One of the devices that we use in multiplying expressions is to use our generic rectangles. And so you could set up a generic rectangle, put the 2 minus 5I as one set of dimensions here, and the 3 plus 8I is the other set here, and then go through the process. 2 times 3 is 6, 3 times negative 5I is going to be negative 15I, 2 times 8I is going to be 16I, and then 8I times negative 5I is going to be negative 40. Now be careful here, this is going to be I squared, I times I. But we haven't talked about, at least in this video, we talked about it in class, but in this video we haven't talked about what happens when we raise I to different powers. So let's actually go deal with that really quickly. We know I is equal to the square root of negative 1, so what about I squared? Well, if I square the left, I need to square the right. And if I square the right, the square and the square root cancel, so I'm left with I squared is equal to negative 1. And so if I go back over here and think about this, then this becomes negative 40 times negative 1, because I squared, as we said, is negative 1. And negative 40 times negative 1 is just a positive 40. So now I'm going to combine the positive 40 with this 6 up here to get 46. Then I'm going to combine my 16I with the negative 15I, and I'm going to get I. And so my answer, well, after I do all the simplification, is this 46 plus I. So just set up the generic rectangles and multiply it out. Remember, I times I is I squared, so that becomes negative 1. And then just do the rest of the arithmetic. The other day we were going through how to do some division. And so if I did 2 minus 4I divided by 6 minus, let's say 6 minus 5I. In order to rewrite this as the standard form for a complex number as a plus bi, we're going to go through and multiply by what we called the other day the complex conjugate from the denominator, the number on the bottom. So for 6 minus I, my number on the bottom, I'm going to multiply, I'm going to use that and multiply the numerator and denominator by the conjugate, which means I need to take the opposite of the imaginary part. So leave the 6 alone. The real part stays whatever sign it has. The imaginary part becomes the opposite. So instead of subtracting 5i, I need to add 5i. So the numerator here needs to be done using the generic rectangles. If you need, or if you have another way of multiplying together a set of binomials like this, then go ahead and do it. Or if you need to use generic rectangles, that's fine. Just give me correct answers. So that becomes 12 minus 24i, and then we get 10i down here, and then minus 20i squared, which, remember, I squared is negative 1, so this all becomes 20 here once we simplify it. And then when I combine these, 12 and 20 make 32, and then 10i and negative 24i make negative 14i. And then I'm going to divide by what I get when I multiply 6 plus 5i times 6 minus 5i. Now we said in class, when we went over why this was true, that when we multiply a complex number and its conjugate together, we always end up with the real part squared plus the imaginary part squared. So this is going to be 6 squared plus 5 squared, which is going to be 36 plus 25, or 61. So if I go back over here, this is all over 61. And to write this in the usual way that complex numbers are written, I'm going to separate it into 2 separate fractions, and that's going to be the answer. Alright, so let's talk about raising I to various powers. So if I raise I to the first power, of course that's just I. As we've already talked about, if I raise I to the second power, or I square I, we get negative 1. But what about if I cube I? Well, I cubed is the same as I squared times I, using our properties of exponents. And so we already know that I squared is -1, so this becomes -1 times I, or just negative I. And what about I to the fourth? Well, I to the fourth is I squared times I squared. That's one way to think about it. And we already know I squared is -1, so this is -1 times -1, or just +1. And then we can continue with this pattern. If I take I to the fifth power, then I get I to the fourth times I, and as we just saw, that's 1, I to the fourth is 1 times I, which becomes just I. We're back at the beginning again. If I take I to the sixth, then, well, what's that? There's a number of ways of thinking about this, but we can just take it as I to the fifth times I is an easy way of looking at it. We already know I to the fifth is I, so this becomes I times I, and we're back to I squared, and we should know I squared is -1. And so we notice that as we work through higher powers, we're cycling through the four different values: I, -1, -I, and 1. And then it starts over again. And so this allows me to use that relationship to figure out I to some really large power, and or any power that's a whole number, positive whole number. And so if I had, like say 714, well, what would that equal? Well, since it cycles every 4, what I could do is divide 714 by 4 and then see what happens. And so, 4 goes into 7 one time, so this is 4. Subtract, you get 3, then it goes in there 7 times, there's 28. And then subtract, get 3, 34. This is 8 times, and 32, and subtract, and we get a remainder of 2. And that's the key part to this, the remainder of 2. Because I to the 178th power, since, how do I want to say this? I'm sorry, not I to the 178th power. I lost my concentration there. 714 is 712 plus 2. The remainder of 2 is right here. So since 4 goes into the 712 178 times, then I to the 712 is just going to be 1, because 4 goes in there evenly. So this becomes just I squared, because the other part was 1. And this remainder of 2 becomes my new exponent. That was not my best explanation. So I paused the recording, and I was writing and talking, and I don't remember when I paused it. And so I might repeat some of the things that I was just talking about. And if I did, I apologize. I to the first power is equal to I. This is what I was talking about a moment ago. And you may have only seen me draw this out without talking about it. So if that's the case, I apologize. I squared, as we mentioned earlier in the video, is -1. So what about I cubed? I cubed is I squared times I, using our laws of exponents. And as we saw a moment ago, I squared is -1. So -1 times I is just going to be -I. So I cubed is -I. What about I to the fourth? Well, we can break down I to the fourth in a few different ways, but the easiest way, in my opinion, is to write I squared times I squared. 2 plus 2 is 4 in the exponent. So that's -1 times -1, which makes just 1. So I to the fourth is equal to 1. What about I to the fifth? Well, I to the fifth, you can write that again a number of different ways, but let's think about it as I to the fourth times I. Well, we just saw that I to the fourth was 1, and 1 times I is I. And so we're back to the start of the pattern again. So if we're looking at what's going on, let me get something here to... sorry. So over here we had we had I, then we had -1, then we had negative I, and then we had 1, and now we're back to I again. So this pattern is going to repeat. And so if I look at I to the 6th power, that's going to be, we could look at it as I to the 4th times I squared. And so I to the 4th is 1, I squared is -1, and so this works out to be -1. And that's the next number again. And so this pattern, because this pattern repeats every 4th term, or it has a cycle of 4. So here's the first one, the second one, the third one, and the fourth one. It starts over again. So we can use that to figure out how to figure out what I to some large power might be. I to some whole number large power. Every 4th, this is the key one right here, every multiple of 4 will always be 1. I to the 4th is 1, I to the 8th is 1, I to the 12th is 1, and so forth. So that's what I want to base this whole process on. So if I raise I to the 671st power, what I need to do is figure out the nearest multiple of 4. Okay, so 4 goes into 671 times, or 671, well, it goes in there once. 4, subtract, bring down the 7, goes in there 6 times, so get 24, and subtract, get 3, goes in there 7 times, 28, and subtract, and get 3 again. That's the key right there, is that 3. So 671 minus 3 is 668. Why do I care about that? Because 668 plus 3 is going to be 671, but the key point to this is that 668 is divisible by 4. So if I raise I to the 668th power, then I know, since 668 is a multiple of 4, that means that's going to be 1. And now I just have to go to the third one after that. So I to the 678 is 1 right here, and so then I go 1 more, 2 more, 3 more, or to I cubed, that 3 right there, I cubed, and we know I cubed is going to be negative I, right? I cubed is negative I like we have over there. So that's how you can figure out how to take a really large power and rewrite it to a smaller power. So if I raise I to the 1249th power, well, what would that be? So I divide 4 into 1249, and 4 goes into 12 3 times, goes in there evenly. 4 goes into 4 1 time, goes in there evenly. 4 goes into 9 twice, and then that's 8. 4 times 2 is 8, with a remainder of 1. Do the long division or use your calculator. The important point here is this 1. When you get that remainder, you know you're going to be 1 after you're going to be 1 level after I to the 4th, because you have a remainder of 1, so this is going to be I to the 1st power, or just I. Alright, so we've done a lot with the imaginary and complex numbers. I hope that was helpful. Go study.